Have you ever wondered how Elon Musk's SpaceX spacecraft dares to reach Mars? We will unravel the secrets behind this monumental interplanetary endeavor. From dazzling power to the challenges of landing on Mars, get ready for a fascinating journey through space and innovation. Spacecraft power. The power of SpaceX's spacecraft, known as Starship, is an unprecedented technological achievement. Propelled by the Super Heavy booster, this ship has astonishing capabilities to overcome the challenges of interplanetary travel. Its powerful propulsion is essential for escaping Earth's atmosphere, where approximately 9.4 kilometers per second of delta V is required. This initial launch sets the foundation for the mission to Mars. The key lies in understanding the concept of delta V, the change in velocity needed for space maneuvers. Once in low Earth orbit, Starship makes a stop to refuel, leveraging the advantage of a previous orbit to reduce the amount of delta V needed to reach Mars. However, the journey to Mars isn't just about acceleration. The critical moment comes when landing on the Martian surface. Unlike escaping Earth, landing involves significant deceleration. This challenge is complicated by Mars' orbital speed, which is slower than Earth's. Landing on Mars requires careful fuel management. Starship, fully loaded in low Earth orbit, has a potential delta V of around 6 to 7 km/s. The strategy becomes crucial, considering approximately 9.5 kilometers per second is needed to reach the Martian surface. The solution lies in intelligent maneuvers and efficient use of external forces, such as atmospheric resistance and Martian gravity. In this complex process, atmospheric resistance plays a key role. Starship performs precise maneuvers, diving into Mars' atmosphere to harness resistance and decrease speed. This is strategically repeated to achieve the necessary velocity for a smooth landing. Despite these challenges, SpaceX tirelessly works on improvements. The next version of Starship will be designed with larger fuel tanks and enhanced Raptor engines. These upgrades aim to increase efficiency and, consequently, the spacecraft's delta V potential. The power of Starship doesn't just reside in its engines but in its ability to navigate the intricate challenges of space physics. This vehicle represents the forefront of interplanetary exploration, paving the way for a future where humanity can step onto Mars and beyond. Journey from Earth to Mars. The journey from Earth to Mars is a monumental undertaking involving overcoming gravitational and atmospheric challenges. After escaping Earth's orbit, the Starship, propelled by the powerful Super Heavy booster, refuels in orbit before embarking on the long journey to Mars. The strategy for landing on Mars is intricate. Atmospheric entry involves harnessing aerodynamic resistance and Martian gravity. The spacecraft executes calculated maneuvers, diving into the atmosphere to gradually lose speed. This process is strategically repeated to adjust the speed and ensure a smooth landing. As the spacecraft plunges into Mars' atmosphere, aerodynamic resistance and gravity become crucial allies. Precise turns are made to leverage these forces and adjust its speed. Each maneuver is designed to conserve fuel, a critical resource for landing success. This journey is more than a space odyssey, it's a cosmic dance between advanced technology and physical principles. Each phase represents a milestone in space engineering, with SpaceX perfecting everything from engine power to landing strategies. This journey doesn't just signify progress towards Mars, it's a step toward a future where humanity could become an interplanetary species. The Starship unravels the secrets of space, pushing boundaries and challenging what was once deemed impossible. Each phase of this journey represents a monumental achievement in interplanetary exploration and a step towards the cosmic horizon that awaits us. Technical challenges and future solutions. The technical challenges in landing on Mars form a symphony of hurdles that demand constant innovation. The difference in orbital speed between the spacecraft and Mars, coupled with the steep inclination of the Martian sky, presents formidable obstacles. To overcome this, SpaceX is immersed in enhancing the Starship, seeking bold technical solutions. The atmospheric resistance on Mars, thinner than on Earth, implies that the spacecraft relies heavily on gravity for deceleration. This underscores the need for precise atmospheric entry strategy. SpaceX addresses this challenge by designing intricate maneuvers, leveraging external forces to optimize fuel usage. The weight of the spacecraft, crucial for landing, adds another layer of complexity. landing with a fully loaded ship requires significant motor power. This is where design efficiency and SpaceX's constant pursuit to increase Starship's delta V come into play. Future solutions loom on the horizon. SpaceX is in the process of developing Starship V2, a longer version with expanded fuel tanks and additional vacuum Raptor engines. The third iteration of the Raptor promises higher efficiency, opening the door to more delta V potential. Other long-term strategies include the possibility of establishing an outpost in Phobos orbit, Mars' outer moon. This would enable refueling, providing the spacecraft with enough delta V to tackle the most challenging part of the journey. Despite these technical challenges, Elon Musk's vision persists: to build a self-sufficient city of 1 million people on Mars. Resolving these challenges not only represents a technical breakthrough but a significant step toward interplanetary exploration and colonization. In this journey into the unknown, SpaceX faces monumental obstacles with the conviction that humanity can overcome the seemingly impossible. The future of landing on Mars is woven with threads of innovation and determination, promising a fascinating saga in the history of space exploration. Exploring new frontiers, adapting the Starship on Mars. In the quest to conquer Mars, SpaceX faces an unusual challenge: adapting the Starship to the Martian atmosphere. Beyond the technical challenges of landing, the spacecraft must adjust to the specific conditions of the red planet to ensure its functionality and durability. The Martian atmosphere, primarily composed of carbon dioxide, contrasts significantly with that of Earth. This change raises crucial questions about the aerodynamics and resistance that the Starship will experience during its atmospheric entry. How will the spacecraft behave under these unique conditions? Extreme temperatures on Mars, with lows that can plummet to -90 degrees Celsius, also pose challenges for the spacecraft's materials and systems. The adaptability of the Starship to these hostile conditions is essential to ensure its structural integrity and long-term functionality. Martian gravity, approximately one-third of Earth's gravity, impacts the flight dynamics and landing maneuvers. How will this reduced gravity affect the stability and control of the spacecraft during critical descent phases? Furthermore, the potential presence of Martian dust adds an additional layer of complexity. The Starship must not only face the challenge of landing on an uneven surface but also cope with fine particles that could affect sensitive systems and components. The answers to these uncertainties lie in SpaceX's meticulous engineering and design. Adapting the Starship involves not only overcoming landing challenges but also ensuring its functionality in a unique Martian environment. Exhaustive research, testing, and simulations are crucial to anticipate and address each variable at play. This unexplored chapter of space exploration raises not only scientific and technical questions but also philosophical ones. How will the Starship coexist with the Martian environment? What unexpected discoveries await us in this new terrain? As SpaceX ventures into this uncharted territory, the adaptation of the Starship on Mars represents not only a technical achievement but also a bold leap toward the possibility of sustainable human presence on another planet. The Martian Odyssey is marked not only by the challenges of landing but also by humanity's ability to adapt and thrive in unexplored cosmic environments. The human factor in the Martian Odyssey. While SpaceX tirelessly works on the technology needed to land on Mars, a fundamental aspect often overlooked emerges: the adaptation of the human being to the Martian environment. Beyond technical challenges, the mission to Mars raises crucial questions about the mental and emotional well-being of future colonizers. The duration of the journey to Mars, which could extend for months, poses significant psychological challenges. Confinement in a confined space, separation from Earth, and the prospect of solitude can profoundly impact the mental health of astronauts. How will the team manage tension and monotony during interplanetary space travel? Arriving on Mars introduces a different set of psychological challenges. The Martian surface, with its desert landscape and lack of familiar stimuli, represents a completely unknown environment. Adapting to Martian gravity and the absence of a blue sky could influence the emotional well-being of colonizers. How will they psychologically adjust to a world so different from what they have known? Social interaction on Mars also raises intriguing questions. Forming a self-sufficient community involves not only solving technical challenges but also creating a solid social fabric. How will human relationships develop in an environment where every action and resource is crucial for collective survival? The importance of interplanetary adaptation is reflected in SpaceX's planning. In addition to technical infrastructure, Elon Musk and his team meticulously consider how to mitigate the psychological impact of the mission on astronauts. Strategies such as the inclusion of simulated green areas and technologies that mimic natural cycles aim to maintain the mental and emotional health of colonizers. The Martian Odyssey, ultimately, is not just a quest for new technological horizons but also an exploration of human resilience in the face of the unknown. Adapting the human factor on Mars not only drives the feasibility of colonization but also raises fascinating questions about humanity's resilience and ability to thrive in alien environments. In this new frontier, the conquest of Mars is both a technical endeavor and an introspective journey to the limits of human experience. If you like the content, don't forget to subscribe and don't miss a video.